All right, so welcome to the video lecture series on Introduction to Computer Networks. This is part 2 of our lecture on the Internet architecture, and we will jump to the point from where we left off. And that is going to be where we start introducing different terminologies in the Internet architecture hierarchy. So first of all, we have what we call POPs, or point of presence, that is the same as the small scale ISPs, which provide local access connections to the users so that they can connect to the larger internet. They are alternatively also called access networks, basically smaller ISPs which provide the multiple point of presence locations for end users to be able to connect to the internet. A little high up in the hierarchy, we have the regional networks. And regional networks are basically groups of smaller regional internet service providers, and they are connected into a larger network as a group. And as the name suggests, this is very specifically related to the geographical location of these access networks for the smaller ISPs. Something in the middle, which provides only the connection but not a particular form of internet service, is what we call the internet exchange points. That they are just connection points and provide gateways for large-scale ISPs to be able to connect to each other. And finally, we have what we call the Tier 1 and Tier 2 ISPs, and they are very large-scale commercial ISPs. In most cases, they have national, international, even continental coverages. So they are global scale operators, not too many in today's world, and they are located all over the world to provide these large ISP services to the smaller access nets to connect and form the overall internet architecture. On the side, we have something that we call provider networks. So provider networks are private networks that basically connect data centers or servers to the internet, and in most cases they actually bypass the Tier 1, Tier 2, and even the regional ISPs. Common examples would be, for example, Amazon. They have their data centers across the world in different countries. For example, there are Amazon servers on the East Coast, on the West Coast. There are servers in Ireland, in Japan, Singapore, and all of these data centers for Amazon are connected with a private network, and that's something that we call the provider network. However, even though this is private, they still need to be connected to the overall internet, and that is why we see this provider network also being a part of this hierarchy and may also be connected through IXPs, the internet exchange points, to different ISPs, or even directly through peering links. And just to give you an example or an idea how dense they could be, so Tier 1 ISP, for example, Sprint, just if you look at the map of North America, you will see all of these points which are provided as point of presence of the POPs, where you see the connection to the users, that is, the connection provided to the end terminals, and also to the peering links for connecting the network to the larger internet. So this is just to give you a basic idea of how large and complex the internet can actually be. So now let's see how we can actually be able to connect to this complex network of networks that we call the internet. We have already established the fact that this is something that we call the access net, that is the network that allows us to connect to the larger internet. And the first case that we'll look at is the digital subscriber line, or the DSL connections. So DSL connections, they use existing telephone cables to connect to what we call the central office. And they are basically connections where we have data over the DSL phone line, and this goes to the internet. And if we have voice over the same line, it actually goes to the telephone network. So there is something that we refer to as the splitter, and the splitter is able to identify what kind of signal is actually passing through the DSL cable, and based on that, it splits the signal stream into the internet network or the telephone network. Upstream is generally less than 2.5 megabits per second. That is the upload rate, and the downstream is around 24 megabits per second. And this is kind of the basic internet connection that we have seen over the years, that allowed users to connect to the larger internet. More on the motor end, the access networks now provide cable services, which are cable networks, and formed using what we call the hybrid fiber coax cable, or HFC. And this is very commonly known as the broadband internet that you probably have heard a million times already. One thing that the hybrid fiber coax cable provides is what we call asymmetric download and upload speeds, which means that the rate of download or the rate of upload vary a lot. And if you just compare the rates, for example, the downstream goes up to 30 megabits per second, and the upstream is around 2 megabits per second. Network cable attaches homes to something that we call the ISP router, and the ISP router allows a single connection which runs through a neighborhood, and based on the location of different user endpoints or homes, they kind of spill out connections from that single line. And very similar to the previous case, they also have splitters where using the same cable you can use cable TV and also the internet along with a cable modem. And at the end of the cable, this is something that we call the cable modem termination system, or CMTS, and these are basically the same as the POPs provided by the cable network ISPs. If you look at home access networks, which are very simple use cases of internet connectivity, we have an incoming connection from the head end or the central office based on a DSL or a broadband connection. And then you have a DSL modem or a cable modem based on the type of connection. However, in most cases, you have a router or a firewall to provide the conversion of this connection into the internet connectivity or the data-enabled connectivity. Eventually, we also have, in most cases, Wi-Fi routers placed in our homes. And today, most Wi-Fi routers actually combine the features of the router as well as the Wi-Fi access point into one single device. And eventually, we have all of these home devices, phones, laptops, PCs, etc., connected to the Wi-Fi or to the wired part of the network. On the other hand, if you look at enterprise access networks, which are slightly more complex and a bit more heavy duty than home access networks, we have what we call institutional link to ISPs. So these are much more high bandwidth connections with a higher guaranteed speed. And the institution, which could be a campus or a large corporate office, they have the main institutional router. And inside the network, there are a set of these servers which provide different services, for example, web services, mail services, email file servers, and VPN servers, etc. And from that point, we also have what we call these Ethernet switches, which are basically splitters of Ethernet connectivity, and they allow us to split our wired connection into multiple connections, as well as connect Wi-Fi routers to our switches so that we can connect wirelessly to our LAN. So they are typically used in companies and universities, and there are many different transmission rates which is supported in this kind of setups. And also the institutional ISP can basically lease high bandwidth lines paying a higher price. Wireless access networks, which we commonly see today at homes, they are basically the wireless LANs, right? So they are provided within a building, typically around like 100 feet coverage, and maybe in most cases go up to 7 gigabits per second. And there are many different versions which I've already looked at in wireless LANs. On the other hand, there are also different other modes of wireless access networks to provide end users the connectivity to the internet, and they are provided by wide area wireless access providers. Most commonly, if you are using internet from your phone, using data and not connected to the Wi-Fi, you are being a part of the wide area wireless access network. So they are provided by the cellular telco operators, which have a much larger coverage, and however, they are a bit lesser speed compared to the wireless LANs that we use at home. The examples could be 3G, 4G, LTE, and the upcoming 5G standard as well. And we have so far already looked at the different ways end users using the point of presence, the POPs, can connect to the internet. However, we also need to have a basic idea of how the internet edge, that is the point where the user is connecting to the public internet network, can be secured. So the first item which are usually in place are the firewalls, and they have something that we call access control lists. So these are basically rules and policies which define how the incoming and outgoing traffic needs to be filtered. A common position to place the firewall is right at the edge where the internal network connects to the public internet. Next, we have something called intrusion prevention systems, as well as intrusion detection systems. The difference between intrusion prevention and detection is in its name. So intrusion prevention systems are more restrictive in nature. On the other hand, intrusion detection systems have a good monitoring system. So they overall, both of them, they are continuously analyzing and tracking the malicious activity over the internet. They are able to track multiple login failures, and also may be able to identify denial of service attacks. For example, someone is sending too many requests into a corporate network. They can identify those DOS attacks. And eventually, the primary objective is to continuously monitor, and if something happens, to alert the network administrator. Finally, the third item, which is also very useful in providing a secure connection to the internet, is something that we call the demilitarized zone, or in short, DMZ. And this is a separation of the LAN devices from the public internet by creating a semi-private zone. So if you see here, anything which needs to come from the internet into the web server can come to the web server here, but the internal server is protected while the user is accessing the web server. So the inside zone, or the private network, is completely protected from the internet. However, these are a small set of servers which can be required to be exposed to the internet, which includes web servers, email servers, etc. And in those cases, we provided with a weaker firewall up here and create a semi-private zone so that it could be accessed from the public internet.